Good afternoon, all. I'm seeing that there are only three of us. Maybe the others don't want to come to class. I'm going to give you a few more minutes and then come back.
Right. Mr. Sean. Mr. Sean.
Good evening.
Have the students graduated from the course? Hello, anybody, somebody?
Hello, sir.
Yeah, I'm just checking to see if your classmates have graduated. The exam went already?
Not that I know of, sir.
Okay, just checking. All right. You know what? It's now 5:30. This is half an hour into the class. Give me another 5 minutes and then I'm gonna start. I'm sorry. I'm starting. Mighty warrior, great in battle, Jehovah. All right. So let me start off by saying Happy New Year to you all. And I trust that this year will bring forth all the plans that you have stored in your hearts. I pray that this year will be a year where we can all celebrate the passing of this COVID virus, just being very hopeful, and that we can return to some level of normalcy. I pray for you that in another couple of weeks you'll be successful in your exams. Um, this year is going to be a critical year where you will sit series of exams, first semester, second semester, and summer semester. So this year is a critical year for you all. I wish for you and your family every good gift that the Lord has in store for you and that will live out your true potential. So my other question is, you guys had um, any internet challenges over the Christmas holidays? Anybody had disturbance in their internet service?
No, sir.
No, sir.
Okay. Okay, I hear you, Shaz. I hear you. I hear you. Anybody else? Any had trouble with your internet?
No, sir.
Mm-hmm. Krishna, you had problems with internet? Abiana, Arthur Lee, you had problems with internet?
No, sir.
Yeah. So me I wonder, oh, me not even say a happy new year in the group. Me not see no best wishes here out to the teacher, to the classmate. And I say, you know, I this I keep it 2022. Me say, all right. I too will remain silent until I get to class. I'll break the silence. So I'm just happy that you guys are well and that you never had any internet problems and that it was intentional. With that said, let us go. Um, ouch, ouch. We we were wrapping up. I had a sudden break in my flow because where I thought Rockstone, okay, this has to be a joke. So let me go again. Okay, it was a joke. um, I had prepared some notes and I thought I lost it. So yeah, so you guys play rough because I was going through some applications of differentiation and integration and galang things are fine and then I hear it blurt out, sir, I really don't understand what is happening in class since last week. And I was like, oh crap. And it put a damper on everything. But nonetheless, let me ask you, what area in the last part of what we're doing was a little fuzzy for you? Just allow me to just do a quick run through of that one. Was it the stationary points? Hmm.
Well, for me, sir, is the sketching of the graph.
The sketching of the graph. Okay. What about the others? Talk to me. I need to know where to start, please. Háblame, háblame, háblame. All right. So I guess you guys understand the stationary points. So it's just a sketching of the graph. So let me go back to the sketching of the graph then and then move on. I don't understand what that means, Sean, so I'll not even respond. Could you just go over it or go over what? No, I can't. I can't. Let me tell you why I can't. In the student meeting on Monday, I wanted to slap whoever said it, them silly. That the week of the 24th of January is your study break. So I have this week, next week, and the following week. I have 3 weeks with you. And in the 3 weeks, I have, let me show you. I have L'Hopital's rule to do. I have solving first order differential equations to do. And there are 4 types. Variable separable has 4 cases. I have to go through all 4 of those. And then I have to go through, well, I did this already, integration of exponential functions. I did that already with you, but I mean, it won't kill me if I do a quick revision. I did some fixing of my notes. My notes was somewhat all about, I think what I did when I did integration, I just did all the integration under one, so I kind of separate them. Then I need to differentiate explicit and implicit exponential and logarithmic functions. I prepared some stuff for you right here. So that is the last unit. And then the second to last unit that we're in now, I have stationary points. And I have implicit differentiation. And what else do I have in here? Applications of integration under the curve. And yeah, so first order differential equation, L'Hopital's rule, integration of logarithmic and exponential functions, 3, area under the curve, and implicit. I have 5 things to look at. So really and truly, I'm not going to do that. And put myself in a situation where I cannot complete the syllabus. If there is time, oh Lord, you know I'll do that. If there is time, I will definitely go ahead and have that done. But for now, I have to know what it is I need to do. What I can do tonight, I can do a 1 question. I can do a 1 question as a revision. That's the best I can do. I'm trying to find a question. All right. So I found one here. I found me a question. All right. Okay. So
Evening, sir. Happy New Year.
thank you, Sash. Same. Many happy returns to you and yours, dears. Many happy returns to you and to you. Um. Oh, come on. All right. So let me share my screen here. X cubed minus 3x squared. All right. So what we are going to be doing is looking at a question here. And my question is, y is equal to y is equal to x cubed minus 3x squared minus 24x. I'm not going to be playing with you tonight. All right, so just make sure say you just relax yourself. All right, so the question would say, having given the function, the question would say, given the function rate y equals all of that, evaluate the stationary points. That's like about 6 marks. So we need to evaluate the stationary points. Now, to evaluate the stationary points, I must differentiate. To evaluate the stationary points, I must differentiate. So what I'm going to say, dy by dx is going to be equals to 3x squared minus 6x minus 24. All right. Minus 6x minus 24. Okay. I think I just saw code. So now, for stationary points, dy by dx is equal to 0. For stationary points, dy by dx is equal to 0. So let us look at our dy by dx. I'm going to let something not going right. Something not right. Something not right. So I'm going to let 3x squared minus 6x minus 24 to be equal to 0. What can be done to that equation to make it simpler?
Factorize.
Factorize, no.
But before I factorize, I want to factorize, you know, but before I factorize, what do I need to do? Is there anything common in that question?
X.
Is it 3 common to 6, common to 24, and common to itself?
sir.
All right, so I'm going to divide 2 by 3. Why, sir? It makes life so much easier. So I'm going to have x squared minus 2x minus 8. Tell me if you agree with that.
Yes, sir.
So I'm going to factorize now. And in factorizing, remember I'm multiplying the coefficient of x squared by the constant. I'm multiplying the coefficient of x squared by the constant. Now, what is the coefficient of x squared? Coefficient of x squared is a number in front of x squared. The coefficient of x squared is a number in front of x squared. What number is in front of x squared?
1.
And what is a constant term?
Minus 8.
Good. So when I multiply 1 by negative 8, I'm going to get negative 8. So I'm going to prime factorize. I'm going to prime factorize and say 2 into 8 goes 4 times. 2 into 4 goes 2 times. And 2 into 2 goes 1 time. All right, so I have those 3 numbers that I need to play around with. Now, looking at it, I can see that when I multiply 2 by 2, I'm going to get 4. And then now, 4 times 2 is 8. But remember, you know, I need a negative 8. So one of the numbers, either 4 or 2, supposed to be negative. Which one should be negative? And why?
The bigger one, because
Why?
it's a negative 6x. Or rather 2x, sorry.
Very good, because I'm going to negative 2.
Negative 2.
Very good. So my factors are going to be I'm not going to do this tonight, you know. Like, seriously. My factors are negative 4 and positive 2. Negative 4 and positive 2. Hold on a minute. Let me change the tip of this pen. Let me see if changing it would make a difference. Rockstone, but that's not different. Mhm. Hold on, guys. Mighty warrior, great in battle, who is he? All right, let's see now. If this makes a difference. All right, so when I multiply -4 by +2, I'm going to get -8, which is what I want. And importantly, when I add -4 to +2, I'm going. And when I add -4 to +2, I'm going to get -2. So I know I found my factors. So this is what is going to happen now. I'm going to rewrite to say x squared minus 4x minus 2x minus 8 equals 0. Oh, Jesus, help me, Lord. And I prefer to write this so that you can see it based on the questions that came. Then I'm going to group. Then I'm going to have x squared minus 4x in one bracket. All right, guess what? It worked beautifully for me last night. It's too early in the school year for me to sing. Let me forget about that. I really wanted to write so that you can see what is happening. I've already done the question. Let me see if I can share another document with the question. What a good thing for me, always prepare myself. Yeah? Let's go. So starting with the question again, I'm trying to find the stationary points. what is happening here is, this is my function, y is equals to x cubed minus 3x squared minus 24x. In order to find the stationary points, I must find dy by dx. When I have found dy by dx, I will set it equal to 0. dy by dx, then I set it equal to 0. So I'm going to have 3 times x is 3x. I reduce this by 1 to the second power. Negative 3x squares, and I differentiate negative 3x squares, I will get a negative 6x, which is this. And when I differentiate 24x, I will get a negative 24. So this is my differentiation. But remember, for stationary points, dy by dx is equals to 0. The derivative is equal to 0. So that's why I'm going to say let 3x squared minus 6x minus 24 equals 0. So what I'm doing there is setting my derivative equal to 0. I'm setting my derivative equal to 0. As I did before, I'm dividing 2 by 3. Why, sir? Because it makes this calculation so much easier. Then, sir, do we have to divide 2 by 3? No, you don't. Except though, in this case, you'd have to multiply 3 by 24 to get 326, you get 72. Find the two numbers and multiply together to give you 72. But when added, will give you a negative 6. That's too much work for me. I often tell you that I work smart, not hard. So I'm going to divide 2 by 3 to simplify my equation. Then, sir, will that change your answer? Absolutely not. Your answer will remain exactly as if somebody in Trinidad and Tobago decided that they're going to do the calculation one shot without doing any division. Same number of marks, same answer. So what I'm doing here is I would have shown you just now how I would have prime factorized, would have found my factors to be -4 and +2. I did not show you all of this piece here. Factors are -4 and +2. So what I'm going to do here now is to substitute into the question my -2 to be -4 and +2x. Look to see what it is that I would have done there. Do you agree so far? That's what I had on paper just now when I was writing. Here now, I'm going to be grouping I'm going to put 2 of them in parentheses, leave out my middle sign every time, and then put the last 2 in the parentheses. That's the reason we had to go on and find the factors, because as it were, I could not group these 3 terms, this trinomial, because one of them will have 2 and one will have 1. So I had to split the middle term so that this first term, x squared, will go with piece of this term, and the last term, -8, will go with another piece of it. So that's what I'm doing in a grouping. I am putting my parentheses in the first 2, leave out the middle sign every time. The only thing I will say to you right about now is when the middle sign is a negative value, this last sign you have to flip. You have to be very careful. But guess what? Whatsoever sign that is in this bracket has to be the same sign in this here bracket. All right? So what I'm going to be doing here now is to factorize what is common between x squared that is common to 4x.
X.
Excellent. What is common to 2x that is common to 8? Hello, somebody?
2.
Very good. So I'm going to have my x that I'm taking out in the first one. And I have my 2 that I take out in the second set of parentheses. Look at that now. And tell me, do you recognize that x plus 4 is common? Do you recognize that x plus 4 here is common?
X minus 4, sir.
X minus 4, sorry, thank you. Say that to see if you're paying attention, because it's only yellow me here talking to me. You recognize that the x minus 4 is common? I'm factoring it out. It is common, so I factor it out. See here, so? Now, when I take away the x minus 4, I'm going to have x left. See here, this is x. And when I take away this x minus 4, I'm going to have positive 2 that is left. See it right here, so? Plus 2. So this is what I'm going to be having as my factorized form and set it equals to 0. Now, one of two things. Either x plus 2 equals 0. And if x plus 2 is equal to 0, it implies that x is equal to negative 2. Because if I'm saying to you x plus 2 is equal to 0, what number must this x be in order for this to be equal to 0? It has to be the opposite of positive 2. And the opposite of positive 2 is negative 2. Similarly, x minus 4 equals 0. It means that this x has to be the opposite of this negative 4, and the opposite of a negative number is a positive number. So the opposite of negative 4 is positive 4. See it here, so? So we're getting x to be equals to either negative 2, and we're also getting x to be equals to positive 4. So my critical values, remember, you know, when I get my x values alone, those are termed as critical values. So my critical values will be this negative 2 and this positive 4. Those are my critical values. Now, in order for me to find my critical points, I will have to substitute it into the original. What's wrong with me? All right, so we must now substitute it into the original function. We have to substitute it now into the original function. So what is the original function again? That's the original function. So look at what is happening now. So I'm starting off with x equals negative 2. Remember, I have 2 of them. I have negative 2 and I have positive 4. Whichever one you choose to calculate first, that's your business. I can't tell you which one to calculate first. You decide which of them is calculating first. So therefore, I'm going to start with my selection, x equals -2. Anywhere in the function, the original function y, you see x, you put -2. Right? So anywhere in this function you see x, you substitute -2. See here now, watch it. That's my function. It is x cubed, so it becomes -2 cubed minus 3 times -2 squares. See here? Minus 24 times -2. -2 cubes is going to be -8. When you raise a negative number to an odd power, your result is negative. When you raise a negative number to an odd power, your result is negative. Minus 3 times -2 is being raised to an even power, so that becomes positive. So -2 squares is +4. See it here. And of course, this is going to be minus 24 times -2. So -8 is here. -3 times 4 is going to be -12. But a -24 times a -2 is +48. So -8 minus 12 is -20. -20 plus 48 is +28. So I'm getting my y to be 28. Now that I have an x value, x equals -2, and I have a y value to be 28, I know my first critical point or stationary point. Oh Lord, what a question asks us to find. Stationary point. Let me change this to stationary. It means the same thing on the list, but I want to be consistent.
Yeah, I was gonna ask if that needs to change.
Right, it's supposed to be stationary values too. It means the same thing, but just for consistency. Right, so yeah. Okay.
You have it in your explanation. So
Say it again.
you have it in your explanation down by substitute the critical value.
Okay, right. Good. So now I'm combining this -2 with this positive 28 to give me a point. So one of my stationary points is -2, 28. I'm now going to be checking this stationary value of +4. See it up here, so to see what the other value is going to be, the y value. So I can put them together to get my stationary point. So anywhere into the same function, the same original function here, you see x, you are now going to be substituting 4. So it becomes 4 cubed minus 3 times 4 squares minus 24 times 4. See here, so all of this. And then what we're going to be doing is to evaluate it. 4 cubes is 64. 4 squares is 16. And this remains as it is. I'm writing my 64 as it is. But -3 times 16 is -48. And -24 times 4 is -96. -64 minus 48 minus 96 is going to be -80. -80. 64 minus 48 is 16, +16. 16 minus 96 is positive. I'm sorry, it's negative 80. 16 minus 96 is negative 80. So my coordinate will be 4, comma, negative 80. 4, comma, negative 80. So I would have found my stationary points. See, I have two of them. Two stationary points. Two stationary points. Negative 2, comma, 28 and 4, comma, negative 80. Now I need to classify these. The question asks me to find a coordinate of the y-intercept. Uh-oh. The y-intercept says to us that is the opposite one. So if I'm asked about the y-intercept, that means the x value is supposed to use. So them asks us to find the coordinate of the y-intercept. So it means that I need to put x equals 0. It asks us to find the coordinates of the y-intercept. The coordinates of the y-intercept is when x is equal to 0. And in order for you to find the coordinates of the x-intercept is when y equals 0. You're putting the opposite one to be equal to 0. The opposite one. So this is found when x equals 0. So into my original question, so recall, that's my original function. Anywhere in the function I see x, I put 0. That means y is equal to 0. So my coordinate of the y-intercept is going to be, see the 0 here for x, and see the 0 here for y, 0, comma 0. All right. Any questions so far?
No, sir.
So the answer for the y-intercept, you're going to put x equals 0. Now, I need to classify the stationary points. I need to classify the stationary points. So I'm recalling what the first derivative is. Remember, I differentiated the question, and I got 3x squared minus 6x minus 24. This is what I put here, 3x squared minus 6x, same thing. I'm just recalling what the differential is. I'm only recalling what I would have differentiated up top, and so that it is the ease of my calculation when I come to it. I don't have to be going up and down. All right. So now, to do the classification, remember the first one I did the graphical method. I look at the graphical method. You go up, positive, you go down, it's negative. You're constant across, 0. When you walk across the room, the gradient is 0. When you walk to the bathroom, the gradient is 0. When you walk to the kitchen, the gradient is 0. Well, it's supposed to be 0. When you walk come out the door and upon the ground walk, 0. Unless you live a country where, like where Sasha live, where she live on one hilltop, and she have to be careful or she will roll off. All right?
Negative, sir. Negative.
So once it is that you're not living on a hill and you're living on flat land, when you walk, it's going to be 0. And what is so important for these we call them contractors when they're building their houses, and the mason and the foreman and then people there is to use them level. Just imagine you put a glass on top of your kitchen counter with a nice wine glass with your most expensive wine, or your nice wine bucket with the most expensive wine in there. And because the place is not level, put it down, it just slide off and break. I'm sure you would start speaking in tongues to say, hallelujah, glory to God. In the highest and on earth, peace, goodwill to all men. All right? Among other things, you're sleeping on your bed, And afterwards, you get up, it's to say, but gone to the corner where it is going to be lowest. All right. So that's what a slope is. When I'm going to Ocho Rios and I'm climbing the hill, I'm going on a slope. And if you look to the right hand side, you're on the north-south coast, like up the east, yeah, the north-south coast. When you go and look to the right, to the left of it, you will see they put a little yellow and black sign showing you a little slope and telling you 6%. Sometimes it may say 8%, right? Sometimes it may say 10% or 12%. Now, the higher you go, is the steeper the slope. And you have to be careful because you know you have to turn off the AC. You feel like it now move. The porter could truck them astray and it like, yeah, man, that's what the gradient is. Slope. So I'm going to find the second derivative. Now, what is the second derivative, sir? The second derivative is me just finding the derivative of the function one time and then using that derivative to differentiate it another time. Let me say that again. The second derivative is me finding the differentiation of a function. That is called the first derivative. When I would have gotten the first derivative, in order for me to find the second derivative, I have to differentiate that first derivative one more time. So it now becomes dy squared, d squared y by dy squared, dx squared, d squared y by dx squared. Watch me. This is my dy by dx. I'm differentiating this one more time. 2 times 3 is 6. So I'm going to have 6x here. When I differentiate negative 6x, I'm going to get negative 6. And the differential of this negative 24 is going to be 0. Why again? Why do I?
Answer.
Because it's a constant. Thank you. It's a constant. So I'm going to set I'm not setting that yet. That's the point of inflection. So to classify the stationary point, I'm going to go to my stationary points. There are 2 of them. There are 2 of them. So for case 1, I'm using negative 28, negative 2,28. Then, sir, what if when I was in the question, my case 1 is 4, negative 80? Not a problem. Not a problem. Really isn't a problem. So anywhere in the second derivative, you see x, you're going to substitute your critical point, your stationary point. But it so happens that because we're talking about a single variable function, we have no y values. But in other examples, we will have y values. When you talk about multivariable functions, calculus 2. But for now, we are investigating single variable functions. Let's go. So this is 6 times 2, negative 2, sorry, minus 6. Again, I'm not interested in the overall answer. I'm only interested in whether or not it is positive or negative. I'm only interested in it being either positive or negative. In this case, I'm going to end up with a negative 12 minus 6, a negative 18. I'm not interested in that 18. I'm only interested in that it's a negative number. So with a negative 18, it suggests that we have a local maximum. When you substitute and the result is negative, you have a maximum. When you substitute and the result is negative, you have a maximum. When you substitute and the result is positive, you have a local minimum. So let's go. The same differential that we use in this one up here is the same differential, second differential that we're using. See here? 6x minus 6, 6x minus 6. But I'm going to use the same function, b squared y by dx squared, for you to evaluate the question using the stationary value as point as 4. Anywhere in the function you see x, you put 4. 6 times x becomes 6 times 4, 24. 24 minus 6, bing, 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 that's positive. So because it's positive, I'm going to have a local minimum. Because it's positive, I'm going to have a local minimum. Because it's positive, I'm going to have a local minimum. It's negative, I have a local maximum. If it's equal to 0, I have a saddle point. Equal to 0, saddle point. You know what a saddle looks like? That they put on the back of a horse? It has that lovely groove inside here. Okay. Any questions?
No, sir.
Okay, moving on. So I'm now going to determine the point of inflection. I am I prepared some notes for my CAPE students. And I thought about you. And I said, when I get to this point, yeah, I thought about Uno, but you never think about the teacher when Christmas comes, Sash. Not even a Merry New Year.
Sir, you know, no, to be honest, you know, sir, I think about you and the cake, you know, sir. Sir, me that go call you, but me I say, sir, now go give me free show. So
you say, you are going to call me, you know, because of the cake. All right, look at this. So for my CAPE students, they are doing trigonometry. Thankfully, you're not doing it. And I'm asking them, I'm giving them this graph. They need to decide whether or not it's a sine graph, a cosine graph, or a tangent graph. And from this, they need to decide, they need to determine different features on the graph. Now, for those of you who I taught Foundation Concept 3 in terms of completing the squares, oh my Lord, this thing comes in beautifully with it. Watch me now. So when I speak of the point of inflection, your graphs will look like this, you know, but this graph is a specific graph. The point of inflection, watch me, let me spotlight it.
Sir, are you showing a graph?
Oh, cockroach. I need to do a new share. Thank you.
Sir, me just like
I'm doing a new share. Forgive me. A lot of things happening. It's a new year.
So this is what you put in Desmos.
Yes, that's what I put. That's what I put in Desmos. I mean, Desmos is like the next best thing to sliced bread. Once I discovered it, it became my best friend, my very best friend. Watch me. Point of inflection is the midpoint of this turns like an N, so it's a maximum point up here. So, and this turns like a U, it's a minimum point. Between points, the minimum, maximum, or maximum, minimum, whichever one you want to call first, the midpoint would be run about here. So talk truth.
Yes, sir.
So how you know that? All right, let us count. 1, 2, 3, 4, 5, 6. Sir, why is up at 6? Because the maximum up here, so if we carry this across, so all right, watch now. Let me start from the maximum. Come down to this minimum at -5. 1, 2, 3, 4, 5, 6. No, the point of inflection is like a midpoint. So half a 6 are 3. So it's going to be 1, 2, 3. So see here? So this point here is the midpoint. Now, look at how we do the solution. And yes, I use my Christmas to prepare notes for my students, including you. So to determine the amplitude, which is the height of the graph, we need to estimate the point of inflection. The point of inflection. They don't know the point of inflection yet because them don't do I don't teach them calculus yet. So I tell them, say you hear more about this later in module 3. This is just module 1. So I'm saying to them that this is just the midpoint between the peak and trough of the graph, the maximum and minimum. God, I'm going to say peak and trough. So Lord Jesus, what is peak and trough? That's the maximum and minimum. So this is something that you are using now. All right. So that's the point of inflection. All right. So you talk about B and H and them something there. All of those things come back to haunt them. So they will know and come up with the graph. Say, boy, so the graph is going to be 3 cosine x over 2 minus 2. All right. Based on all of them, something here that them supposed to know. All right. So what's the point in showing you that? Your point of inflection, how important it is, especially when we're sketching our curves or even interpreting our curves. All right. So let us look at the point of inflection now. So I'm going to find d squared y by dx squared. I'm finding the second derivative. I'm finding the second derivative. And when I find the second derivative, I'm going to set it equals to 0. I'm doing the second derivative, and I'm going to set it equals to 0. But I've already done the second derivative to do the classification, local max or local min. So I have the second derivative already, which is 6x minus 6 from up top here. So see here, 6x minus 6. So I have my second derivative. I'm going to set my second derivative equals to 0. So I'm going to let my second derivative, 6x minus 6, equals 0. And then, of course, it's going to imply that x is equals to 1. It implies that x is equals to 1. Because 6 times 1 is 6, and 6 minus 6 is equals to 0. I'm going to put x equals 1 into the original function. Sir, everything you have to go to the original? Absolutely.
Sir, where the 1 come from?
I've come in. Where the 1? Which one? This one?
Yes, sir.
See it now? Divide both sides by 6.
Okay.
See it?
Yes, sir. Yeah.
All right. So I'm going to put x equals 1 into my dy by dx. Oh, not the dy by dx. Into my original function. I copied the wrong something. Forgive me here. Jesus. This is the function I want to copy. Copy. Into the original function. All right. So it's going to be anywhere in the original function I see x, I'm going to put 1. So it's going to be 1 cube. See it right here, so 1 cube minus 3 times 1 squared minus 24 times 1. 1 cube is 1 every single time. So is 1 squared. And I'm writing back this negative 24 times 1. So I'm taking out the 1 here, and negative 3 times 1 is negative 3. And negative 24 times 1 is negative 24. Now 1 minus 3 is negative 2. And negative 2 minus 24 is negative 26. So my point of inflection is going to occur at 1, comma, negative 26. All right? And then now, it asks me now to sketch the graph. Then it asks me now to sketch the graph. So in sketching the graph, everything that I would have calculated now must be on the graph. So my stationary points would be -2, 28 and 4, -80. Murder. If this is 20, 25, 30, 35, 40. That means this is 5. This is 0. Okay. I don't like how this graph looks. Anyhow, my local minimum, which is one that looks like a U, occurs at -2, 28. My local maximum, this is maximum, can't read. My local maximum will look like an N and occur at -2, 28. And believe me, this is -2, 28. If I actually add up, you know what? Nah, I'm not going to do it. If I actually add up Desmos graph, I'll be able to, no, I want to show you something. What was the function again? X cubed minus 3x squared minus 24x. Oh, so that's why I did a graph like that, because it was looking almost very ugly. All right, let me go up. All right, so that point is supposed to be -2, 28. Can you see that?
Yes, sir.
Yeah, man. So that's the point that we calculated. And the other point is supposed to be, and that's a maximum. It shapes like an N. That's a maximum. It shapes like an N. And then now, can I reduce this? Oh Lord. And then the minimum supposed to be 4, -80. All right, see there. 4, -80. We calculated it. So the critical points must be on the graph paper. But you know what is important? The classification, because when I did my classification, it told me that -4, sorry, it told me that 4, -80 is a local minimum. Sir, how you know the difference between minimum and maximum? Maximum shaped like an N, because if it is negative, the minimum gets shaped like a U. So you see this thing here is like a U down here, so a very ugly looking U. It almost looks like a V-ish, but that's the point though. That's the point I'm making. Then now, our point of inflection. I did say to you that the point of inflection is a midpoint. Oh Lord. All right, let me see if I can reduce this. The point of inflection is a midpoint between here and here. Let us see if we can estimate the point of inflection. Look at it and see if we can estimate where the point of inflection is. All right, so if in the interest of time, so from this point to this point, I'm going to get my point of inflection. So look at what I'm doing. I'm saying this sits exactly on the line. So I'm passing this 1 block, this 1 block, 2 blocks, 3 blocks, 4 blocks, 5 blocks, 5 blocks, and 1.5. That means it's going to be 2.5 blocks. So it's going to be 1 block, 2 blocks, 2.5
Around
blocks.
22.
Yeah, 2.5 blocks should be around about here. So, and then it's going to be about anywhere up here, so anywhere up here, so anywhere up right here, so you can have the point of inflection, right? Why I can't do this is because this piece here is not sitting exactly on a line where I can just go ahead and just read it off. But this is going to be 1, 2, 3, 4. Because remember, I said the point of inflection is a midpoint, you know, right? So if I go 1, 2.5, 2.5 is going to be 1, 2, 3, 4. 2.5 is going to be right here, so. And then I'm going to go to, that's about somewhere right here, so. So I'm going to click right here, so. I'm going to click right here, so, and call it 1, 26. 1, negative 26. 1, negative 26. Let me go back to the my question now and see what it looks like. I don't remember what the question is. You want to sit here? 1, negative 26. Can you see what I'm talking about now? Do you believe me?
Sir.
Yeah, man. So that's what the point of inflection is. Let me go back to it. So it will be 1, negative 26. It will be 1, negative 26. Right up in here, so. All right, my hand get nervous, but you know, you get the gist. Anyway, right here, so in here, so right, I'm gonna have a 1, negative 26. All right, so that's what the point of inflection is. All right, and then I don't have these points here to show where it cuts the x-axis away from the 0, 0. The 0, 0 is one of the other points that I had. I had a 0, 0 where it cuts the x-axis, which is right at the 480. Where's the 0, 0? See it right here, so I have the 0, 0 here. So the point I'm making is you would have seen on a graph paper on the sketch that I just plotted using decimals, this negative 1, sorry, this 1, negative 26. You'd have also seen the 4, negative 80, the negative 2, 28. You'd have also seen the 0, 0. So all the points that we found doing the stationary point question, we can represent those points on the graph. And anytime they ask you to sketch the graph, all the points that you would have calculated must reflect on the graph or on the sketch, not the graph, because you're not plotting it, you're sketching it. Must be reflected on the sketch. So on the sketch, I must see this point. I must see my point of inflection. I must see my point of inflection somewhere up in here, so. That's 2. I must see this 3, and I've got a point here to be 0, 0, 4. Those 4 sets of points must be on it. If not, you start losing marks. And that's the end of that question. Then, sir, how the question takes so long to finish? Don't worry about it. I was going through a
And you
whole lot
said
of
it's 6 marks, sir?
No. All of this is about 20 marks. 6 marks was
Okay.
only for 6 marks was only for
Only the first question, the first
first
part.
part here to do this. Yeah, to calculate up to the negative 2 and the negative 4. Sorry.
Amazing.
Up to here. To calculate the stationary point was 6 points. But to do the whole question is a 20 marker. And one of those questions will come on the exam. One of those questions will come on the exam.
Okay, sir. So when with the graph part of it, sir, is
Say it
it that
again?
we should the graph when we're doing the graph, the sketch graph,
Yes, you're going to require to sketch it out.
we should draw it ourselves, or can we take a snippet from this one?
No, miss.
Okay.
Don't be like. I thank you for that question. I thank you for that question because some students in the past, when I give them like a piecewise graph to sketch, because I remember we have the piecewise graphs to sketch also. when I give them a piecewise graph to sketch or the stationary point question to sketch, they use Desmos and sketch it and give it in there as a final answer. You know what them get done.
Yeah.
All right. So I've given you the tools that you can use to help you. And when you're studying, so it is that you can see when you make your sketches to see if you're right. But when you're doing the exam, you have to do it. You can't just not do it. You'll get into serious problems.
Sir,
Mm.
so one of these days before class, before our time expire with you, can you show us a pencil to paper sketch of what you're expecting, please?
That would have been tonight. That would have been tonight. But you joined late, and I had I don't know if you saw where I had some problems with my writing tablet.
Yeah, I realize.
Yeah, so I just had to just abandon it. So that was the plan for tonight.
What you can do, sir, is draw it on piece of paper and just send a picture in the group.
No, I prefer to draw it first before I see what I'm doing, and then no, we take it from there. So I could try that for Thursday's class. I'm going to see if I can doctor this thing and try for Thursday's class. So it is that I can demonstrate. Matter of fact, I've invested in a document camera, but this computer I'm using is too old to operate with it. So I'm going to see if I can borrow a computer or another device. Check to see if what another device that I have, if it can work. If it can work, I can actually show you live how it is that I'm drawing the stuff in real life time. Show you how I draw the stuff. All right, are there any questions?
No, sir.
All right. I'm not going to touch on anything else. Just to say that I have some implicit differentiation to do. And hold on 1 minute, please. Right, so we can do, so on Thursday, all being well, I want to do, I'm going to show you some sketches. Yes, I'm going to see if I can use that device, that other device that I have access to show you live how the sketches are done. When that is done, since we have 3 hours, when that is done, I'm going to be moving into my other area. Over the Christmas, I had an opportunity to go through the syllabus again. And I was suggesting to you that I did only maybe 1 or 2 questions. I know no more than 3 on the stationary point, not stationary point, I'm sorry, on the substitution method for integration. And I said to you that I doubt this is on a timetable on the syllabus, but I'm going to do it nonetheless. I did look at it and it is very much there. So I will generate a few more of those examples so we can go through that, because they can give it to you. Them can be troublesome and flung it on a paper. And then I'm going to look at some implicit differentiation, and that will take us through this unit so I can start the other unit and wrap up. Remember, the last week of this month, they are saying that it's supposed to be study week. I do not want to be in breach where I have to go beg you one of the days. I want you to be able to do your own preparations without my interference. So let us do a countdown. So we have 3 weeks exactly. And of the 3 weeks, just bring up my calculator here.
Sure, that's a 1 week to prepare for exam.
Yeah, they're saying the week of the 24th to the 29th, 28th. It's supposed to be your study week. So I have 6 classes with you. 6, that's 30 hours with you. 30 hours. We would have used What am I talking about? Lord Jesus. Lord forgive me. 15 hours. All right? I'd have 15 hours with you. We would have used up 2 of those 15 hours today. Up to, I normally give you 15 minutes to come into class. And up to 5:15, there were only 4 of us here, 3 students and myself. This is crunch time. I will finish the syllabus, no doubt, but I want you to finish the syllabus along with me. This will come Thursday at 7 o'clock. And when I give you your grace period of 15 minutes to get in, at 7:15, all being well on Thursday, I shall be starting my class. Do some more sketches, move into the other topic, so that I can finally move into, finish off this, so that I can finally come next week, all being well, move into my final area. I want to dedicate those 2 weeks to the final area. And why? In particular, to my differential equation, my first order differential equation. All right? So just to say, please bear in mind. Okay. Any questions? If not, we will close. Are there any questions?
Sir,
Mm-hmm.
sir, you did read the grade.
I did what?
The grade, I think you had said.
You know,
something.
say I was in a meeting today and I spoke eloquently about it towards the end of last semester. And let me just check on something while I talk to you. And somebody raised it in the meeting today again, and I spoke about it. A-E-O-R-I-O-N. I just need to double check something quickly, and then send my supervisor a message to tell her, say, I'm going to release the mid-semester grades. Just checking on something here. It's coming up. Which class am I looking for? Calculus 1. Class list. Calculus 1. Not fall. Undergraduate evening. Hold on. Oh, sorry. It's supposed to be 2021 because I'm saying you guys don't exist. Okay, there you go. There you go. All right, I'm seeing a few more students registered. Now I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 students I've seen registered. And I have 21 of you, so that means 7 of you are unregistered. Let me just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, yeah. It's 12 and 9 is 21, right? So I have 9 of you unregistered. And you know yourselves, please check your status, log on to your Arion. The same thing that I'm just logging on to is my Arion. And I'm seeing the ones that are registered. So what I may do is just, let me just send her a message and then hear what she says. And for sure, I can send this now to the registered ones, the grades, the registered ones. Guys, please sort out the registration because we don't want.
And the papers to sir.
Which papers?
You said you give us the marked papers.
Yeah, man, that's what I'm talking about.
Okay.
So when I said grades, I'm not. You guys know what grade you're gonna get already because that those have been posted on Editors from before I came to class. Just before I even tell you I'm at the papers. I told you that I'm at the papers at the end. That come on long time. What I'm saying
Sir,
is that,
disappear now though.
huh?
Them disappear now.
Or they disappear? Oh, thanks for reminding me. Somebody called me and told me this morning, you know. Thanks for, I mean, somebody from a lecturer called me and asked me something. I need to do something. Right. So I will sort out for you. So be good and be safe. I will hold
Sir, before you go,
Uh-huh.
will we be getting another assessment before the final exam?
This has to be a New Year, Shanna. Shanna, my heart
Yes, I'm
full.
here.
My heart full. You know why my heart full?
Why?
At the first you unmute and ask me a question without me ask you to unmute. I will think about it.
Okay.
I will think about it, honey bunches. I'll think
And
about it.
also the
Mhm.
EduCosoft assessment, test, homework, and so forth, do those carry a mark?
Absolute. Wait there, yeah, man. 20%.
I mean, a mark that will contribute. How much?
20%.
Oh,
Yeah, man.
okay.
20%. And then the mid-semester 20%. So what Shannon is asking is, you know, if I would give another mid-semester to put you guys into even a better position, and I will look seriously into it. I thought about it. I've been thinking about it. But it's for me now to tell you what areas to work on, you know, etc., etc. So, yeah, have a good one. We'll talk later.